Before we show you how to get metadata out, let's review how we put metadata in. We borrowed this slide from our Metadata Input Tools presentation. It shows a block diagram of the tools that we offer that enable you to collect data from a variety of sensors and sample those on each frame of incoming video in real time. The key template is a tool that ITS offers that enables you to design a structure to collect data from a multiplicity of sources. The data concentrator uses the key template to organize the raw data that's coming in from sensors, data acquisition systems, and other items that may be connectable to a PC, and maps the data from those sources to the key fields of the key you designed. It then wraps each sample into ITS insertion commands and sends the payload packets wrapped in the commands to an inserter of ours or a 6520 Fusion recorder. The output from our metadata time text inserter or the Fusion recorder as it's recorded will be the incoming raw video and time relevant samples of the data. So now that you have video with metadata inserted into it on a frame by frame basis, the next step would be to how to extract that metadata and use it for analysis and view the video in synchronism with that. Any of our HDSDI time, text, and metadata inserters, or the 6520, can also be used to extract the data that's there in KLB packets without buying any extra equipment. Our HDSDI inserter, for example, our 6055 is shown here, can be set to extract the metadata from the incoming video without removing it from the incoming video, so it can be used for other things, go to other recorders and other locations. It can also extract the payload packets themselves and through one of our configuration utilities create a PFD file, which is the data on a frame by frame basis. In the PFD file we have a header which tells us about the channel it was captured from, the metadata key, what the length of the key is, and the status of the timestamp. It also will capture the timestamp and all of the related mount data that was inserted into the metadata frame itself, along with the video. You can use key read then, or download video, which has a key read-like function in it. Tell it about the key. You can see the PFD file and actually read the data, format it in human readable form in the manner specified by the key design, and display that for use on a frame by frame basis or walk through all the frames. And then key read or download video can be told to extract that and export it to a CSV file, also in formatted form, with all of the information, the header information, the timestamps, as well as the data on in every field. And each record created is a record that can be tied back to a specific frame of the video clip. As I said during the previous slide, the 6520 recorder can also extract the metadata. What's unique about this, however, is that if there's a previously recorded clip on the SSD or even in the DDR memory, the output channel is actually also an inserter channel that is always in decode mode. And using the configuration utility, we can tell the 6520 to play back video and overlay the metadata that was recorded with the video itself. So you can see frame by frame the data that was captured. It can be played back and formatted in human readable form in accordance with your key design from the key template. And in playback mode, the recorder can do single step, it can play fast and slow, and a linear range of speeds in between. The 6520 can also be told to extract that data as payloads and end up in a PFD file, just like KeyRead can use and Download Video can use. Using the key template information, that data then is parsed and displayed in human readable form and formatted in accordance with your specifications of the key. And then KeyRead or Download Video can export that to a CSV file, which you can use in Excel or other programs for detailed analysis. Taking a closer look at KeyRead, you can see here this is our sample key, and in our sample key we show all of the fields, there are 43 of them, and each one is displaying the data formatted the way our sample key specifies it to be displayed. The key template is read by KeyRead, so it knows how to do the formatting and parse the packet data. You can also, with KeyRead, decide whether you want to automatically step through each record of the data that was captured in the PFD file, so you can actually observe how data changes. And then in the end, you can export that data to an Excel file or a CSV file that can be used by Excel. And in that file, you will see this is the header information right here. The header information tells you how long the key is, in this case 180 bytes. It tells you the channel that it was collected with, which happened to be channel 3 of a 6055, which packet number it was. As you may recall, we can insert up to 2 KLV packets after the timestamp on line 9. So in this case, it's indicating the data came from packet 1, that the timestamp status was a 1, saying that it was locked, which is replicated here in the status, and then the key itself, the number itself, that was used for capturing this data. And that gives you a way then to use each record independently if you choose and know which key is needed to know how to parse the field and format it. There was also the timestamp itself, and this is actually the quantity of microseconds since January 1st, 1970. This is actually the microsecond value of the timestamp, so that you can use conversion algorithms that will tell you what the date and time was. This is actually the microseconds from the Unix epoch right here. And then what follows is each field of data of the key. In this case, using the sample key, there'd be 43 fields that follow. And each one of them is the data that was captured for those fields, formatted the way the key template told you to format it. Download Video is a support tool specifically for the 6520 video recording instrument. In block diagram form, a 6520, this one is the rack mount version of it shown, can record clips and insert KLV metadata packets in accordance with your key in a number of different ways, the data concentrator being one of them. During playback, you can play back the live video, as I said earlier, but also you can extract the clip and download it over UDP in UDP packets. That is, in effect, the uncompressed video that was captured by the 6520 at the time of recording. it will contain everything. Everything in the Hank space, which means any audio, payload data, and items of that type in the Hank space, and it also captures all of the KLD metadata that was captured in the Hank space. That can all be downloaded to a PC. Now recognize this is uncompressed video, so these are very large files, and generally not really playable by any PC because of the amount of processing that needs to be done to create them. However, download video also lets you transcode that video to an MP4 or an AVI format and extract the metadata also on a frame-by-frame basis. Once in MP4 or AVI form, your PC then should be able to play that video, provided you have the correct decoder. And will also, if you've extracted the metadata, and there was metadata present, with your key information, we'll be able to display that metadata much the way KeyRead displays it. What's different here is that this video frame and this data are coincident, meaning the frame that's being shown and the data that's being shown is the data captured when this frame was recorded. And so now you have a means to look at the video and look at the data at the same time, step through them, and you can even do this with clean frames. Download video then can also be instructed to export the data on a frame-by-frame basis to a CSV file, just as KeyRead does. So now, download video can see the directory of the clips that reside on the SSD, or if they're only on the DDR, extract those and bring them down to a PC as UDP packets. It can transcode them, it can extract the metadata, and you can view the metadata and export it to a CSV file. Some of the other things that download video can do, it will display the key that was extracted. It will give you the length of that key. It will give you the timestamp, and in this case we've converted it to a Julian date. When you're on anything but the first frame, it will actually show you what the time difference is. So if you know you have 30 frame a second video, you know this number should be 33 milliseconds. Or if it's 60 frame a second video, you know it's 66 milliseconds. As you're playing, if you watch this, you can tell whether you're skipping frames in your PC or not that was captured. And many PCs will not actually be able to keep up with 1080p 60 video. You can actually tell it to slow down and play at different rates, down to 1/8 speed, and find a speed in which every frame will be displayed and you can see the data in every frame. The other thing that you can do with download video is actually pick a field. In this case it was field 13. Pick a field, set a value for that field that has a criteria. In our case, in this example, we're showing it equals a value, and search on the data. It will search on the data, find the field that meets your criteria, and display the frame that that data was captured with. So now you can find a point of interest and see the image and the data collected at the same time that image was collected. Thank you for listening.